Cantor did a wonderful thing in the decade, Georg Cantor, famous German mathematician, did a wonderful thing in the decade from 1870 to 1880. He founded the theory of transfinite numbers, or just infinite, if you like, past the finite. Everybody else stopped counting somewhere at the finite stage. Cantor actually copied the usual way of counting, starting at 1. But it's nicer to count starting at 0. So I'll start at 0. It doesn't make very much difference. 0, 1, 2, ... Everybody stopped, say, at 2,417 or some other finite number. Cantor carried on, imagining counting an infinite collection, getting to the end, and then you have a problem of what the next number is after all the finite whole numbers. And Cantor originally called it infinity, but it doesn't behave like the infinity that people sort of know from calculus. So after a time, he rubbed a little bit of the infinity symbol off and took the Greek little omega as his notion for the first infinite number, the first infinite counting number, omega. And then there's omega plus 1, omega plus 2. You see, you can't afford to go on inventing different names all the time. You know, there are an awful lot of finite numbers even. And so there's the number well, in England we call 101. In America you call 101. Really 101 is a little bit nicer, or 100 plus 1, 100 plus 2, and so on. We haven't invented separate names for all those. Once we've got 100, 101 is the next number, you know. So with Cantor, omega plus 1, omega plus 2, ... omega plus n typically, and then omega plus omega, which is omega times 2, omega times 2 plus 1, omega times... blah, blah, blah. It goes on and on and on and on and on and on and on. They're wonderful things, the Cantor's ordinal numbers. It means counting numbers. You know, Cantor is one of my really great mathematical heroes. We all ought to have Cantor as a mathematical hero. He has had more influence on the way mathematics is done than anyone else. Not only that, his influence is not just on, you know, the thing that you might know about, the creation of set theory, and we discuss everything in terms of sets nowadays. We formalize mathematics in terms of sets. But Cantor founded the Deutsche Mathematische Gesellschaft. He founded the International Mathematical Union, which conducts the international congresses. He wanted to make sure that, he socialized, unionized, perhaps I should say, mathematics. He wanted to make sure that the international congresses, particularly the first one, would be a success. It wasn't at all clear that the French would come. Cantor went and visited Poincaré, and Poincaré said effectively, well, I'll come, but I can't speak for my colleagues. I'll try to persuade them to come. And then when the Congress opened, no French delegation. That was a terrible thing. I'm tearing up now, because after a time, the French delegation marched in with Poincaré holding the flag, and about 20 people came in, and everybody burst into spontaneous ovation. Anyway, that's an aspect of Cantor's influence on mathematics that you might not have been aware of. When I speak to people normally, they don't know that. They know about his set theory. They know about all sorts of other things. So you'll have gathered that I quite admire Cantor.